Alright, you mathletes, this video is about showing you how to use the different subtraction algorithms when it comes to working with decimals. So let's take a look. The first one that we're going to talk about is the trade first. But I'm going to actually go ahead and cross out trade and write steal, because it's not really a trade, and I think you'll see what I mean when we get to it. So we'll call it the steal first strategy. What you do, it's very similar to the column strategy that we use with addition. As you can see, I've already placed some columns to separate our place values. Here's the ones, here is the tenths, here is the hundredths, and here we have the thousands. So there's our place values. And I'm going to go ahead and put a placekeeping 0 there just to make everything nice and neat. Alright, with subtraction, we're going to start to the right and work our way over, as we normally do with math problems such as this. Working with the least set of place value. So 0 minus 1. I cannot do 0 minus 1. So according to the math book, it says we're going to trade with the hundredths place. We're going to trade. I'm just going to say it's a steal, because the hundredths place is not going to get anything back for this. So we're going to steal one of the hundredths, make this I'm going to do this in red. Make this a 7, and borrow that hundredths over here. Now I can do 10 minus 1, which is 9. Okay, now we go to the hundredths place, who had a hundred stolen. I know, it's so upset. So now we have 7 minus 9. We can't do 7 minus 9. So the hundredths place is going to take the example that the thousandths place set, and it's going to steal from the tenths place. Take that. Now that's a 3. And now what was once 7 is now 17. 17 minus 9 is 8. Very good. Now we go over to the tenths place. It's already set up to do 3 minus 2. That works. 3 minus 2 is 1. Then we go to the ones place. That one's all good too. 9 minus 7 is 2. Last thing that we have to remember is this number is not 2,189. It is actually, I'm going to go ahead and move these out of the way. Whoops, that didn't work. There we go. Had to pick them from the bottom. This number is actually 2, bring that decimal point down, 2 and 189 thousandths. That is our trade first, or if you want to be clever with it, called the steal first subtraction algorithm when it comes to working with decimals. A lot of fun, right? Our next wonderful algorithm when it comes to subtracting decimals is called the, let's get a different color, the counting up strategy. So as you can see, the problem that we're working with here is 9 and 48 hundredths minus 7 and 291 thousandths. So we're going to try the counting up strategy. Now it took me a couple minutes to actually figure out what was going on with the picture in my math book, but I think I got it. So pay close attention, and let's see if we can wrap our minds around this one, okay? So to count up, it's very much like the partial quotients method or partial products or partial sums. You're going to kind of set the tone for how you want to work this problem out based on the numbers that you pick. So we're going to start with the smaller number, which is 7 and 291 thousandths. So we're going to start there. That's the first thing that we write when we're going to work this strategy, okay? Start with the smaller number. There's a little arrow, okay? Now, I'm going to choose, I'm trying to work my way up to 9 and 48 hundredths. I'm trying to work my way up there. So I can pick whatever number I feel like is easy to use mental math with, to get closer there. So I can see that if I add, I know we're adding to find subtraction here, but if I add 9 thousandths, if I add 9 thousandths to this, that's going to give me 9 plus 1 gives me 10. That becomes 10. That's 3. So I get a nice and even 7 and 3 tenths. Okay, or 300 thousandths. This is the same as 3 tenths. Okay, so I'm moving closer to 9 and 48 hundredths. Now what should I add to that? Well, let's say I'm going to keep working, trying to make whole numbers here. So I'm going to add, let's add 7 tenths. 7 tenths to that. And we'll add a couple placekeeping zeros, make it 700 thousandths. If I add that, bring down those zeros, 7 plus 3 gives me 10, carry it over, Now I have an even number of 8. Even though I have all those zeros after the decimal point, that's just still 8. Okay? Now I'm at 8, and I'm trying to get to 9 48 hundredths. Well, I'm just going to add what I know I need. I need a 1 to get to 9. I need a 4, and I need an 8. And we'll put a placekeeping 0 there, just for fun. Add them up. 0 plus 0 is 0. 8 plus 0 is 8. 4 plus 0 is 4. Put that decimal point down there. Don't leave that. And 8 plus 1 is 9. There we have it. 9 480 thousandths, but really it's the same as 9 48 hundredths. Pretty cool. Now, the final step, okay, we did all that work to get to that point, but now we have to keep track of what we used to get there. So we have to add all of those numbers up. So we need to add 0 so 9 thousandths plus 7 tenths or 700 thousandths. Oops, didn't want to do that. Hold on. Don't panic, everyone. And I want to also add 1 and the 480 thousandths right there. So I'm adding everything that I worked with, okay? Add them together, I get 9, 8, 11, carry it. I get a 2, and ooh, that is an ugly 8. My goodness. There we go, let's fix that. That's better. So I get 2 and 189 thousandths. That is the correct answer to the subtraction of 9 48 hundredths minus 7 291 thousandths. Seems like a lot of work, but once again, you got to know more than one way you're doing the right thing. I thought that was kind of fun. All right, on to the next one. We've come to the most patriotic algorithm, the U.S. traditional. This is what you guys are used to. This is what you like to use. This is what you complain about when I say, oh, let's try partial quotients or this or that. Like, come on, Mr. Kirchhoff, let's do the American style, okay? Keep it American, yeah. America rules. So let's do this. Okay. Nothing new. You guys are familiar with this. 9 48 hundredths, same number we've been working with. 9 48 hundredths minus 7 291 thousandths. Before I get started, I'm going to throw in a placekeeping 0 here just to keep it nice and tight and organized. I like the visual of it. Keeps me organized and keeps me sane because I'm a bit of a neat freak. 0 minus 1, can't do it. Need to borrow or steal, as I guess I've been used to using. Make that a 7. Carry over that 1. We have 10 minus 1, which is 9. 7 minus 9 we cannot do. We need to steal it from the tenths place. That's tenths with a THS at the end. 4 becomes 3. Tack that 1 over there on the 7, making it 17 minus 9, which we know is 8. 3 minus 2, that's cool. We can do that. And 9 minus 7, that's even cooler. We can do that. Decimal points pointed straight down, so we get an answer of 2 and 189 thousandths. That is the patriotic American U.S. traditional. I don't know why my voice has to go that way when I say American, but it just has to. Okay, so does yours. That's it, guys. Enjoy those algorithms. Make sure you knock them out in the home link and the math boxes.